Hi everyone, welcome to another Android Developer Lab Plus. We're on a different day of the week today where it's obviously not a Thursday, unless of course you're watching on YouTube, in which case it might be. You might be in the future. Anyway, so welcome. We are actually coming to you today from Hong Kong. So even though Tony and I are on different screens, we are actually right opposite one another. I'll let Tony introduce himself.
All right. Hi everyone. My name's Tony. So Anchor and I today we are in Hong Kong. So cool.
Right. I'm Anirudh, and I'm here joining from Hyderabad, and I'm the lonely one here, I guess.
Anyway, so thanks for joining us. I'm Anchor Cotwell, normally from the Sydney office, but I'm glad to be here with Tony for once. So today's topic of the week is actually the native development kit, and we have our resident expert Anirudh, who's going to present that to us. So take it away, Anirudh.
Right. Thanks, Uncle. Let me share my slides. Okay. Can you guys see the slides?
Yep.
All right. So the topic for today is NDK, and I'm gonna introduce to you what is NDK. And
sorry, Anirudh, sorry to disturb you. We can see Keynote. We don't see the presentation itself. I think you might have screen shared only Keynote. You need to screen share your desktop in order for the actual presentation to show.
Okay, I'm gonna give it another go.
All right. So whilst Anirudh does that, the NDK is obviously an alternative to using Eclipse and doing Java programming. Well, I don't want to steal Anirudh's thunder, so go ahead, Anirudh.
All right, so everything's fine now?
Yeah.
Mm-hmm. All right, thanks. So first, what is NDK? It's the Native Development Kit, which basically means it allows you to write build and publish native applications, build and deploy out, I should say. So it's actually a tool set, collection of tools, which includes cross-tool chains like the compiler, linker, and build system for native libraries, which you use to write your C++ code, link them against the libraries available as part of the system ABI with binary interface, and as well as your libraries, and include them as part of the Android build system so that they get packaged into your APKs. And we also have a build system which uses Android.nk, the Android makefiles, and this is what you use to build your native libraries. Then, like I mentioned, there are packaging tools available so that when you actually add a native library to your project, which also contains Java code and Android manifest and other activities, it allows you to bundle your native libraries along with your APK so that you can deploy them to the Play Store. And the part that I mentioned about ABI, which is the binary interface or the headers, these are basically the headers available from the C++ headers and libraries available from the Android framework to you to code against. And there are a lot of things about these libraries that you should know, and we're going to look at the basic architecture of how all these components are deployed, so you better understand what these libraries are and why these are the only libraries you should use. So before we begin looking into the libraries and architecture, I want to cover what NDK is not, and this is very important. There are some people who've asked us questions: is NDK a replacement for SDK, or can I just write my code in C++ because I'm better at it? So NDK is not a replacement for SDK. SDK is always and will be the primary choice of development platform for Android, and it offers you tons of libraries through the Dalvik. And the SDK is the primary platform for development. NDK is only targeted for special cases, and we're going to discuss what those cases are. NDK is not the solution for performance issues. So if you have performance issues in your app, do not think that if I use C++ code with NDK, my app is going to be faster. For most applications, NDK will not make a difference, and Dalvik is actually very optimized and provides you with all the memory garbage collection stuff, which you'll have to do manually when writing native code. So it's not always a solution for performance issues. It's not meant for typical applications. So if you have a regular UI list view kind of application where you're pulling data from internet and storing them on data store and showing them on UI and letting user interact, these are your typical applications, and NDK is not meant for those. And it's also not an alternative programming language option, which means like you cannot choose NDK just because you're comfortable with C, C++. But you have to be comfortable if you choose NDK for specific needs of your project, because all the code is written in C and C++ and with JNI glue wrapper. So now when to use NDK? So if you have a lot of libraries that you've written as part of your projects or open source libraries that you would like to use, reuse these native libraries, you should use NDK. So while you can still write your application code in Java, you can actually include these libraries and make those JNI calls across from Dalvik to the native world, and in that sense use these libraries that you already have. Also, if you're writing something that is computationally intensive, for example, a lot of math is involved, you can look at the option of using NDK, because with NDK you can leverage some of the CPU specific extensions for performance, like vector floating point instructions and neon instructions, and these are really fast routines that you can access directly from NDK. So this may be a case where you can look to use NDK if you feel that's that last bit of performance you need to squeeze out from the platform. So we're going to look at some of the supported platforms right now. So we support the ARM v5 instruction set, ARM v7 with the hardware floating point unit, thumb2 and neon instructions. Then we also support x86 architecture and MIPS. So what this means is basically you can use NDK to build libraries or shared objects for these platforms only. So your code has to run on one of these platforms because the binary is generated and kept in a folder, and only these specific platforms are used or are available to you right now to generate those binaries. So let's look at an architectural overview of what NDK and where the different components sit in the system. So if you're a Java developer or you've actually used Java SDK before, you can see there is a Linux kernel there, and then we have a runtime, the Dalvik VM, and then you have all these framework classes and APIs and stuff available to you that's built on top of the runtime, and these are the activity managers and the entire Android framework that's available in the SDK. And then you write your applications on top of this. So the runtime is talking to the kernel using JNI, which is Java native interface. So you can call CC++ native code from Java runtime. But so what happens is that there are some system libraries sitting on top of Linux kernel, and that's where and when I mentioned about a certain set of headers and libraries available to you as an NDK programmer, the reason why that is so, because a lot of the system libraries that we have that are running on top of the kernel, these are not very stable, and there's no reason for them to be stable. We change them across versions as we see fit, and we cannot really guarantee a stable interface over top of this, because this is something that only Android uses, and it's meant for only Android framework and runtime. So while we release different versions, we can make sure our runtime adapts to these changes in these system libraries, but that's not something we'd like to tell you with your apps, because then if you have a new release of the framework or new API SDK release, your apps will start breaking if you're using any of those system libraries that have changed over the version. So what we try to do is provide you a stable ABI, the application binary interface, and this is a set of headers and libraries that are available to you to code against, and we make sure that these are stable. These remain the same over different versions of NDK, so you can always rely on it's kind of guaranteed that they will work across. And then the box that you see that says library, these are your libraries, the libraries that you write on top of these stable ABIs. And then again, you can use JNI wrapper, and your applications can have Java code that can directly talk to these your libraries that are talking to stable ABIs using JNI. So this is an alternative code execution environment that basically is what NDK provides you. So some of the headers that are available to you, uh, and I guess this is pretty much all the headers available to you, and this is what we should be using. So the first one is libc. I think I have a mistake there saying lib. It's a libc, the standard C library, and there's a libmath, the lib compression library, liblog is the Android log system if you want to interact with that, the libdl dynamic linking library, and then we have graphics related libraries like OpenGL ES 1.1.2.0 spec libraries and libgni graphics that can talk directly to your 2D rendering system like bitmaps and stuff, and also to the OpenGL stuff. So these are the libraries available to you. And recently with Gingerbread, well, not so recently, with Gingerbread we added support for more libraries and to basically cater to the needs of game developers. And so there is OpenGL ESRE available to you. There's libegl available to you, and also standard C++ libraries available to you. So these are the only headers and libraries you should use in your program from the system, and not rely on any other system libraries available, because they may not remain the same. So it's very important to note that if you want to support your application across versions, just stick to this set of libraries. So how do you write a simple app? So in terms of project structure, it's pretty much the same. When you create a project, and you can do that by using either Android create project script that is available, or use Eclipse to create a project. And you have a folder called JNI that sits parallel to your source and to your libs folder. This JNI folder is actually where you keep all the NDK code or your native code. So you write your C, C++ library source files, and these may actually be another project that you may already have, and you can just place all that C, C++ code inside this JNI folder. And then you write a build file, android.mk file, and the syntax is pretty easy and it's very flexible. So this is what you need to do to build your NDK code, is write the Android MK file. In this file, you basically describe where are your source files, what source files you need to build, what are the libraries these source files should link against, and the output of the library. So and this is per module. So if in your project you're going to have more than a couple of modules or native libraries that you're building, you will have an android.mk file for each of those. And then on top of that, you'll have an application.mk, which is basically something that is going to delegate the module building to each of these Android MK files. So use the the application.mk file to build all of these Android MK files. Optionally, you can use Java Edge or Eclipse tools, IDE tools, to generate C headers from Java files. So if you're, and with Gingerbread, we introduced something called native activity, and we'll get over there. But before that, if you're writing code for older platforms, what you want to do is in your Java, in your Java classes, you may have in your Java code, your application code, you may have some methods implemented there, and some methods are something that you want to use the native platform for. So you're going to prefix the keyword native in front of those methods in Java. And then you can use Java Edge to generate the headers for these Java files, which actually generates a JNI GRU code, and which you can use to do interop between Java and the Dalvik and the native world. So once you do this step, and this is optional depending on your use case, you would run the NDK build script, which is available, and this is the entire toolchain available to you. So you would run this NDK builds to generate the native shared object or library. And in your Java code, you can load this library by saying system.load library native.so or whatever the name for your module is. And NDK build is part of the NDK, the entire NDK platform, which is available for you to download, and it's platform specific. So this is something you can go and download from developers.google.com. Just along with the SDK, you can find the NDK links to that. So once you've generated the shared object libraries, and system.load library will make these libraries available to you loaded dynamically against the running application. So with Gingerbread, we introduced something called native activity. So before Gingerbread, you would always need to have some Java code in your application and some specific methods implemented in native code. So you would, like I said, you would put the native prefix in front of those methods. So you would say private native int do this something and pass parameters. So with Gingerbread, you can actually write Java-less classes, and you can say my entire activity is a native activity, so you don't have to write any application code. And this is some sort of useful for game developers and something. So if you're a game developer and you have all your input and your UI and everything written in native code, and, you really don't need any Java interface to it. So what you can do is write a native activity. So like I mentioned, it implements a complete activity in native code. So we'll just look at the manifest of how you declare a native activity. So if you see in this slide, there is an activity by the name of android.app.native activity, and this is the activity tag, which has an element called metadata, which specifies the name of a library, and this is the native library we are going to be using, and the value is the activity name, the native activity available. So this will actually make sure that your activity, this will tell the Android runtime that your activity, that there is no Java class for this activity, there is no, the entire activity is implemented natively, and if your application is completely Java-less, you would see that in the application tag we have something called android.hasCodeFalse, which means that there is no Java code, and all the components inside this APK are native. So the entry point for a native activity, if you're writing a native activity completely Java-less, the entry point is Android main. So in your C++ code, you should have this entry point, and this is where your where the runtime starts interacting with your application or passing you the state, and this is kind of similar to the Android activity style. This is implemented as part of Android native glue library, and this is something you will have to link against when you are building your native code. So when I mention android.mk files, where you define your dependencies in the libraries, you would also have to include this library there. So, okay, before we discuss tools and IDEs, there are some important performance considerations with the NDK. So when you are actually, the first thing is the threads that are created in your applications are tied to the process. So sometimes your activity may stop or may pause, and but your thread and your process is still alive. That's actually hosting these activities. That's your application, which spawns a Dalvik VM. So this process may still be alive. So because the process may be alive, if you're using threads in your NDK code, your threads will also continue running. So it's something important you should know when you're writing your application. Although the activity may be out of the screen or may have been paused because some dialog popped up in front, your threads will still be running. So at times you want to choose which threads you should stop at that point of time, or which threads you should keep running. So if you're doing some kind of sound, maybe something you want to stop there, right there, because once your activity is stopped or paused, you don't want to hear any sound from your application. But there are other things that you may need to keep running. So that's an important consideration when writing NDK code, native code. The other thing is because the process is only brought live once, there may be some static initializers in your code, and they will only get initialized once. So if the activity stops and then again resumes, these static initializers will not be loaded again. So you may want to avoid these static initializers and take care of initializing these variables yourself. So as an NDK developer, and also there are other performance considerations and tools and stuff available for you, because it can get tricky and it's not easy to manage memory when you're writing the memory handling routines yourself. So you need to be extra careful. So what we have is, as part of tools and IDEs, we have the ADT20 release now supports NDK building and debugging directly from using the ADT plugin. And this actually uses a multi-threaded GDB, so you don't have to write all the code inside main thread to be able to debug that. There's a link to that tools.android.com/recent/using the NDK plugin, and this is where you can see notes about the support and how to configure it. There are also plugins available, Eclipse plugins available from NVIDIA that can help you do performance and memory analysis for your application. We now We also support the NDK GDB, which is the GNU debugger that you can use, and you can use any GDB. So this actually starts a GDB server on your device and then uses a name pipe to talk to your machine that you're debugging it from. So these are some of the tools available. There are a lot more available from community. There are developers who've come up with complete project generation kits, and some of the companies like NVIDIA have come up with advanced memory analysis tools and stuff. So this is some of the things you can explore, and you should always use this. You should always debug your applications using Gingerbread, because you can debug a native activity, find out loopholes, find out memory leaks, and fix them. So yeah, that brings us to the end of the presentation. We'll now move over to Q&A. Ankur, do you want to take that up?
Yeah, thanks, Anirudh. So we have Anatoly live. Hi there.
Yeah, hi. Do you hear me well?
Yeah, we can hear you.
Okay, great.
Did you have any questions that you wanted to ask us?
Yeah, first of the question is regarding NDK. I'm glad that I joined the session. Actually, as a topic, this is the first hangout I'm attending to, and I was not aware of the topic. But NDK is actually right now in one of my projects. I'm working closely with it. So the first question is, you said that there are some header files which provide to NDK developers. What about STL? Something related to more language, I would say. Are they stable? Or I know that there are three alternatives, not three but two, is STL4 and GNU STL, which we can use in our projects, but are they stable or not? Because you didn't mention them in the list of the available headers.
So the libraries that I've mentioned in the list of available headers, these are the only stable ones and kind of guaranteed to work across future releases. So these are the ones you should stick to as far as Android framework is concerned, or the Android system libraries set is concerned. You can always have your third-party libraries there. But from the systemlet perspective, the ones in the list are there. And then you can always find the updated list on the developer.google.com NDK. If you visit the NDK section, you'll have a list of libraries there, and you should always stick to them.
But as far as I know, some STL libraries are shipped with NDK, but they are not stable, right?
Sorry, Anirudh, just before you answer the next question, we can't see you actually. It's your screen share is still on. You can go over to switch to your... There you go. Thank you.
Thanks. I'm sorry, you said some libraries. I didn't catch which libraries. Some.
Yeah. I mean that STL is a part of NDK.
Right.
There is.
Right.
But it is not listed in the stable libraries. So they ship together, but they are not still stable, right? They are subject to change.
I think there's an issue with WString that we had. I can check and get back to you whether we want to call it stable and make it available, and really want to call it stable officially so that you can go ahead and use. I know it's available as part of the NDK. Maybe I'll get back on this G+ thread of this Hangout and post your answer there.
Okay, just a second question regarding native activity. Imagine that I'm developing some application where I'm going to have audio and video streaming. For example, this will be something similar to what we're doing now, Hangout, targeted on primarily for tablets. And for example, in one part of the screen, I'm going to have, for example, some video frame. Another part, I'm going to have some chat and, of course, audio conversation. Will native activity benefit me somehow? Because as I see it now, I will have. I was planning to use, I would say, a classic Java activity with some, framing with video output, and for example, but my audio-video compression code already is a part of NDK library, which I'm shipping with my application. So, do I have any benefits if I will stick to native activity? Will it benefit me in the performance of this, I would say, video showing, video output? Can you comment?
Right, so if you're using any of those specific instructions, the neon instruction set, etc., for your compression routines and stuff, you may have some benefits in performance there. But otherwise, largely as part of as far as rendering and stuff is concerned on the screen, we wouldn't say that there's any benefit in using the NDK for that stuff. So yeah, it's really up to the compression and all that routines, those computationally intensive routines. And if you want to take some benefit there using the instruction set extensions available on the CPU platform, that's where you should probably look forward to using it.
Okay, thank you. So far, I got no more questions.
Okay, thank you. Ankur, we cannot hear you.
Well, that's embarrassing. I was talking for a good 30 seconds then on mute. But in terms of moderator, we have one question on there, which basically says, how do I send search terms to the Google Search app built into Android? I mean, the answer to this is typically what you would do is you just call a URL, like do a normal Google search. It will actually not go through the Google Search app. It'll basically fire up your browser, and you will get search results through the web page, the mobile site. So I guess my follow-up question to this would be: is there anything particular that you are after in that built-in Google Search app? Because in general, that Google Search app is basically all it is a user interface for doing searches. On Jelly Bean, we added Google Now, which actually handles some Google searches there and presents them slightly differently. But if you do the same search through your mobile browser, you do get the same knowledge cards and the usual results, and they're kind of formatted to match your screen size, and it goes through the browser. So the browser is there. You don't go directly into the Google Search app. So in terms of your results, it should be the same, but I'll be interested to know what else you might be after, why specifically you want the integration with the Google Search app itself. So JJ from Cambridge, if you're able to respond back in a future moderator, that would be great. Just let us know. Let me just see if there are if there's anything else from the thread where we've got the Hangout running, and there isn't. So with that, I guess there's nothing more for today. Thanks, Anirudh, for the presentation on NDK. I'm sure you'll get quite a few questions from developers. It's a fairly common and popular topic about coding on using C++ for Android. So thanks very much, and yeah, we'll be back next week. And next week we'll be back to our regularly scheduled time, which is on Thursdays. So yeah, thanks for joining us, and we'll see you next week.
Yeah, looking forward. Bye.
Okay. Thanks. Bye-bye.